This is on page 102. Perfect squares. So the example A they give us is 4w squared minus 81. Okay. So I need to know some tricks to do this. They tell me it's a perfect square, which means both of the terms in the equation are the square of some number. So if I take the square root, what's the square root of 4w squared? So what's the square root of 4?
2.
And what's the square root of 2w squared?
W.
W. Okay. And then what's the square root of 81?
9.
9. Okay, so there's my squares, my perfect squares. Okay. 2w and a 9. So 2w times 2w, that will take me back to my 4w squared. And 9 times 9 will take me back to my 81. How about my signs in there?
1 positive, 1 negative.
1 positive, 1 negative. So my middle terms all cancel out, right? Okay. So when I'm factoring perfect squares, I just take it down to its binomial conjugate, if you remember that. Same information in both parentheses, one's a positive and one's a negative. So that's our perfect square. Example B is v squared plus a 49. So what's the square root of v squared? V. And what's the square root of 49? 7. Okay. This is a positive though. So if I write it like this, v plus 7 and v minus 7, what happens when I FOIL that out?
Negative 49.
Okay, I should have a negative 49. So if they're both positives, then what happens?
V squared plus 49.
I'd have v squared plus 7v plus 7v plus 49. So my middle terms did not cancel out, did they? Because I ended up with 14v. Okay. What if they were both negative? I would have v squared minus 7v minus 7v.
But you'd end up with negative 14v.
I'd end up with a negative 14v minus 49. So this is considered prime. Okay, there's no combination that will give me a v squared plus a 49. Example C is negative 3n squared plus 48. So they tell me it's a perfect square. Does 3 look like a square to you? No. Okay. So I would want to pull out a negative 3 first. So what do I times negative 3 by to go back to negative 3n squared?
N squared.
N squared. And what do I times the negative 3 by to go back to 48? Okay. Now those are both perfect squares. So what's the square root of n squared? N. And what's the square root of 16?
4.
4. So I have a 4. So I need to use the binomial conjugate, right? I need to make sure I bring my negative 3 down. So I'll have n squared minus a 4n plus a 4n, so those terms cancel out, minus 16. So if they tell you you're working with a perfect square, but your numbers aren't perfect squares, see if you can pull out a factor. So example D is z to the 4th minus 1 over 81. So it's still a perfect square even though it's a fraction. What's the square root of z to the 4th?
Z squared.
Z squared. Okay. So I'll have z squared. And then what's the square root of 1? 81. What's the square root of 81? 9. So I'll have 1 over 9, 1 over 9. One's positive, one's negative. So that gives me my z squared times z squared, z to the 4th, minus a 1/9 z squared, plus a 1/9 z squared. So those terms cancel. And I'll have minus 1 over 81.
You sure? I'm teasing.
Am I sure? I'm sure. We could break it down again because I can take the square root. So let's break
9
it
to 3.
9 to a 3 and the z squared to a
Z.
z. Okay, so I can break it down again. I can go one more step. So let's do that. I've got z squared minus 1/9 times z squared plus 1/9. Okay, then I want to take the perfect square again. So what was it?
Z minus 1/3 and Z plus 1/3.
Z plus 1/3 and z minus 1/3. So z times z, z squared, minus 1/3 z plus 1/3 z, those cancel out, and then I'll have minus 1/9. How about this one? Can I take a perfect square if it's positive?
No.
No. Right? This number has to be a negative or we end up with those middle terms in there. Then I would say z squared plus 1/9. Example E is x squared minus 7. Okay, so this is another kind of trick problem. They tell me it's a perfect square. Can I take the perfect square of a 7? No. But I can be tricky.
Go. Okay, that's just rude.
I know, it's bad. So that would give me x squared minus,
They would
and
cross
then
out.
positive, so they would cancel. And then remember what happens when I square the square root? They just cancel. Okay.
Is there, tell me there's not one like that on the test?
There's not one like that on the test.
Because that's just vile.
I know, it's a trick question for sure. Okay. So back to page 106 in the homework. Let's do perfect squares. 18a is 9v squared minus 1 over 25. So square root of 9, 3, and the square root of v squared, v. So 3v and 3v. And then the square root of 1, 1. And the square root of 25, 5. 1 over 5. One's positive, one's negative. My middle terms I'll cancel. 18b is 25w squared minus 1 over 49. So 25w squared, take the square root. 5w. And the square root of 1,
1,
square root of 49,
7.
7. One positive, one negative, middle terms cancel. C. So v4 minus 1. This one's kind of tricky. What's the square root of v to the 4th?
V squared.
V squared. So I'll have and the square root of 1. So I'll have v to the 4th plus 1v squared minus 1v squared, so those cancel, and then a negative 1. But this is still a perfect square right here. So that one needs to come down one more step.
Yeah, it'll have the v minus 1 plus v.
Okay. So I'll have v plus 1 times v minus 1. Right, and I can't take the perfect square if it's positive. 18d 16z to the fourth minus 81. So square root of 16,
4.
the square root of z to the fourth,
Z squared.
z squared, and the square root of 81.
Right.
So I'll have a plus a 9 and a negative 9.
And the other one could be squared again.
Okay, so then I can do the perfect square again. So the square root of 4z squared,
2Z.
2z, the square root of
Minus
9, plus 3 times 2z minus 3. 18e x squared minus 17. Okay, this is one of those trick questions. Square root of x squared. And then there's not a square root of 17. So I would just write it like that.